Okay guys, so we're going to start a new topic about karyotypes. Before that, I wanted to remind y'all that y'all really need to be keeping up with your own work. It's your responsibility to turn everything in and to make sure you understand everything. If you need help, you can email me or send me a message on Facebook. And I really want to remind y'all that y'all need to start studying for that AP biology test. It's not a joke. You're not going to be able to pass it if you don't study. There's a couple of books out there that you can buy if you want to. I heard the Cliff Notes book is pretty good, but make sure that you buy the 2013 one, because if you buy anything before that, it's not going to be for the right test, because remember the test changed this year, so make sure that you get the right one. So since we've been talking about genetics, I'm going to talk about some chromosomal abnormalities that you can have. And the main way that you get these is if you have problems whenever you're doing meiosis. So y'all remember how we do crossing over, which y'all can see right up there at the top left. So whenever you're doing crossing over, sometimes it doesn't cross over properly, and that can cause a problem with your chromosomes. And the other problem is sometimes when the chromosomes are splitting and dividing during meiosis 1 or meiosis 2, it might not divide properly. So you might end up with an extra chromosome or missing a chromosome depending on how it divides. And the main reason this will happen is, I don't know if y'all remember me telling y'all, but when a woman's born, she's born with all her eggs, and those eggs are frozen in metaphase 1. So since it's frozen like that for so many years, there's a good possibility that there's something that's going to go wrong with all the spindle fibers that are attached to her chromosomes. So when she does use her eggs and it gets out of metaphase 1 and it actually starts dividing, then the spindle fibers, which might have broken off over the years, will not be able to get the chromosome to the opposite side. So you'll have a problem where you'll either end up with too many chromosomes or not enough chromosomes in the eggs. So the way that we look at the different chromosomes is it's called a karyotype. So basically what they do is they would go into the nucleus and they would get out all the chromosomes. And remember, chromosome means colored body. So these all are very colorful, as you can see. And they're going to take all of the colored bodies and they're going to try and match them up. So as you'll remember, I have one chromosome for my mom and one chromosome for my dad for each pair of chromosomes that I have. So I have 23 pairs of chromosomes, but I have a total of 46 chromosomes altogether. But each one has a pair. The only one that doesn't have a complete matching pair is going to be number 23, which this will determine if I'm a boy or a girl. So I could have two X's, which those would match, or I could have an X and a Y, and that doesn't match. That would be if you're a boy. So this is an example of what a karyotype would look like. It's just a bigger version. So I have 22 autosomal pairs, which means those are my normal body cells. Those are my normal matching chromosomes. And then I have number 23, which is my sex chromosome. So this is an X and a Y. You can always tell if it's a Y because it'll be really, really little. So the Y chromosome has very few genes on it, while the X chromosome has a lot of genes. So whenever we talked about sex-linked, most of the problems are on the X chromosome because it's so big, so it has a lot of areas where it could have problems. And the Y chromosome usually doesn't have that many problems because it's so small and very few genes are found on it at all. But there are a few problems that you can get on the Y chromosome. Okay, so you need to know the different types of abnormalities. So the number one type is called nondisjunction, and that happens when the chromosomes don't separate properly in meiosis. So that's when I can get either too many chromosomes or not enough chromosomes. So my two kinds of nondisjunction are monosomy and trisomy. I can also have breakage of my chromosomes where a piece breaks off. That usually happens when I'm crossing over. So that could be in deletion, a duplication, an inversion, or a translocation. So those are the kinds that you need to make sure you know. So the very first one we're going to talk about is nondisjunction. So there's two ways that nondisjunction can happen. It can either happen in meiosis 1 or it can happen in meiosis 2. So the first problem is that homologous chromosomes do not separate properly during meiosis 1. or the sister chromatids fail to separate during meiosis II. So this is just one example. So y'all know that it's supposed to split completely down the middle, but it didn't. For some reason, I had one of these extra chromosomes. So when I made my 2 cells, I had one that looked like this and one that looked like this. So this guy has an extra one. And what happens is that I'm going to make 2 cells that don't have enough chromosomes in it, and I'm going to make 2 cells that have too many chromosomes in it. And these are the 4 gametes. So if these gametes get used to turn into babies, then those children are going to have some type of abnormality. So it's real easy to determine if the error happened in meiosis I or if the error happened in meiosis II. So if I end up with 4 gametes that are messed up, that means that the error happened in the very beginning. That happened in meiosis I. But if I end up where only half of them have an error, so only these 2 have an error and these 2 are perfectly fine, then that means the error happened in meiosis II. There's 2 really important words that you need to know about nondisjunction. The first one is trisomy and the second one is monosomy. So if I end up producing a gamete that has too many chromosomes, it's usually going to have 3 chromosomes. That would be considered a trisomy condition. So 3 for tri, that makes sense, trisomy. And if I make a gamete that only has 1 of the chromosomes when it should have 2, that's called a monosomy condition. So mono means 1, so that makes sense. So remember, I'm supposed to have 2 copies of every chromosome, 1 from my dad and 1 from my mom. If I only have 1, that's a monosomy. If I have an extra one and I have 3, that's a trisomy. Humans have a high frequency of actually having chromosomal abnormalities, but we normally don't see them because most of those embryos are miscarried, so they're spontaneously aborted by the mom. There are a few chromosomes that can tolerate actually having a disruption in the balance, so they can have either 1 or 3, and they won't be normal, but they'll be normal enough to survive. But most of the chromosomes, if you have too many or not enough, or if you have an insertion or deletion or something wrong with the chromosomes, most of the time that child won't be born at all because it's going to be causing too many problems in their hormones and transcription factors and imbalances in their body, and most of the time they won't even develop properly to be born. So if it is a chromosome where you can have an upset in the balance and they are survivable, then those children are going to be born with something that you call a syndrome. So an example would be if I had Down syndrome. That's a chromosome abnormality. Here's an example of how it happens. So it's a trisomy condition, which means that you have 3 chromosomes when you really should have 2. And it happens on number 21, so it's called trisomy 21. And about 1 in 700 children in the United States will be born with Down syndrome. Number 21 is actually the smallest chromosome, so it has very few genes associated with it. That's why your body allows you to have too many or too few, and the baby won't be spontaneously aborted. But it does have enough genes on it to where it will dramatically affect the child. The age of the mom does increase the chances of you having Down syndrome. Like I told you, a woman's born with a certain amount of eggs, so the older she gets, the higher her chances are of having a monosomy or a trisomy condition in her children. So that increases the percent that she would give birth to a child who has Down syndrome. That's why they say that you really shouldn't have children after the age of 40. But there are some people who have children after 40 and they're just fine. It just depends on the person. So as you can see by this chart, as the mother's age increases, the likelihood that she's going to give birth to a child with Down syndrome dramatically increases. So if you're giving birth to a child when you're like 49, there's a 1 in 12 chance that your child's going to be born with Down syndrome. And the whole reason is just because her eggs have been frozen in time in that metaphase 1 position for 49 years. So that's a long time for something to go wrong. Luckily, you can do genetic testing. So amniocentesis is something that you can do when you're in your 2nd trimester. So they'll actually stick a syringe through the mom's stomach and take a little sample of the amniotic fluid around the sac of the baby, and they'll go and they'll do genetic testing on it, and they can tell you right then and there if your baby's going to have some type of chromosomal abnormality or not. There are risks associated with it. I mean, there's a chance that they could pop the sac and you could abort the baby, but those risks are pretty low. So basically you have to weigh your options and decide if you want to know if you're going to give birth to a child who is going to be born with some type of syndrome, or if you would just rather not risk it because you don't like the chances of the fact that this amniocentesis could possibly cause your baby to die. So it's really up to you, whatever you think is more important. The majority of chromosomal abnormalities actually happen with the sex chromosome, so the very last set of chromosomes, number 23. So it provides very distinct different syndromes. So if you could be born XXY, which means that you would have Klinefelter syndrome, but you would still be classified as a male because you do have a Y. So anyone who's classified as a male has a Y. You could get XXX, would be a trisomy female. You could get Jacob syndrome, where you would have an X and two Ys. Or you could have Turner syndrome, which is where you have just an X and nothing else. Okay, so this is Klinefelter syndrome. This is where you have two X's and a Y, and you'll still be classified as a male. It's 1 in every 2,000 births. So they are most likely going to have male sex organs, but they're going to be classified as sterile. It is a possibility that they could develop some female sex organs, but not normally. There is a high possibility that they're going to develop some breast development, and they're going to have a lack of facial hair, lack of underarm hair. So normal male growth patterns are going to be lacking. They will be tall and they'll have normal intelligence, so you won't be able to tell just by talking to them. So if you can see in this picture, they have two X's and a Y on their karyotype. There has been one crazy example of Klinefelter syndrome where they actually had 4 X's, X, 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 and a Y. So even though this person has 4 X's, they're still classified as a boy, and they'll be diagnosed with Klinefelter syndrome. But this example right here is extremely rare. Okay, so this is Jacob syndrome, where you have an X and 2 Y's, so that's about 1 in 1,000 male births, so they have an extra Y chromosome. They are really, really aggressive. These are people who have serious anger management issues. They're usually slightly taller than average, they're more active, they have normal intelligence, they might have slight learning disabilities, they have delayed emotional maturity, which usually often leads to them being extremely aggressive, but they have normal sexual development, so they should be able to have children. So this is a trisomy female where she has XXX. It's 1 in every 2,000 live births. It produces healthy females that are completely normal, and the reason is something called bar bodies. So this is an extremely important idea that you'll have to learn, bar bodies. So in every female we have 2 X's, and one of the X's becomes inactive. So it basically gets smaller and smaller over time, and only one of the X's is activated. So whichever is the better of the X's is the one that your body is going to recognize and use, and the other one just slowly will fade away over time. So as long as this girl has an X, the other 2 will turn into bar bodies and she'll be just fine. Even though those X's are going to turn into bar bodies, the bar body is still important enough during development before it starts wasting away that if you don't have 2 X's, it could be a big problem. So Turner syndrome is where you're born with only 1 X. So this is only 1 in every 5,000 births. The chances of a child actually being born is really unlikely. These type of children with Turner syndrome are usually miscarried. So they have a wide variety of problems. Each one is its own severity, but even though they do have 1 X and the other X would have turned into a bar body, that extra X during development is the big difference between being normal and having Turner syndrome. Okay, so these are the other examples that you need to know. A deletion is easy. It's where something is deleted off of the chromosome. A duplication is also easy to recognize. It's where you have either an extra add-on to the chromosome. So you'll see sometimes it'll be in one long string, sometimes it'll be sticking off the side, but it'll be extra. An inversion is where you'll take a set of genes and you invert them. So it used to be B, C, D, and now it's D, C, B. So that's really hard to see sometimes. They usually will have to tell you something about this in a picture in order for you to see it. And then translocation is where you have a piece of one chromosome that will actually break off and move to a completely different chromosome. So let's say this is chromosome 7 and it breaks off and moves over to chromosome 14. So that will cause a problem in two sets of chromosomes. So this type of issue, a translocation issue, is probably the worst out of all of these. You need to know that deletion and duplication, that happens if there's an error in replication. And an inversion and translocation, these happen when you have a problem with crossing over. So whenever you're crossing over in metaphase 1, these two problems can happen.